we're going to look at area equations. So keywords for these problems is always going to be area. When we have the formula for a shape, you can solve for any piece in a problem. So a formula is an equation, okay? And remember, equations have to have an equal sign, okay? And all of those formulas and equations come from our star chart, okay? So if you look, all of these for area are equations. They have that equal sign. And then we also need to know for the future that we never use a slant. Okay, so in 6th grade, we are going to work with parallelograms, triangles, and trapezoids. So for a parallelogram, we're going to look at our star chart. Parallelogram is right here, and it says A equals BH. So I'm going to write down that formula for a parallelogram. A equals BH. And I need to know that when I have two letters next to each other, there is an invisible multiplication sign. So I'm going to go ahead and put that there. So for that shape, a parallelogram, we need a base and a height. So base is always going to be on top or bottom. So looking at this, my bottom here is my base. That is 12. So this is my base. So my base would be 12. Okay, my height is always going to be straight up and down, and typically it's on that dotted line. So in this one, my height is going to be that 6. So this is my H for my height. And another good trick is always look for that right angle square, and that's going to be base and height. So we have that extra number, that 8. That is what we are calling the slant. So if it is a slant, we are going to mark it out because we are not using slants. That 8 is not going to be part of our problem. So that's a parallelogram. The next thing is a triangle. Triangles have 3 sides. So these are just some different triangles we could see. So the formula for a triangle, if I look at that star chart again, for a triangle is 1/2 BH. So we're going to write that formula down. A equals 1/2 BH. I'll write it here in the middle. A equals 1/2 BH. And we just talked about in between that B and the H, we have multiplication. So if you want to, you can go ahead and put that. And there's also multiplication here. So again, we need a base and a height. So let's go through and label our bases and our heights. So in this one, my base is on bottom. It's going to be that 18, so base. Okay. And my height in this one, we do have that dotted line that we were talking about, would be 7. That is my height. I do have extra numbers. Those are our slants. So this 9 is a slant. You see how it's kind of sideways? And then this 13 is also a slant because, again, it's not straight up and down. So we're going to mark out both of those. We would have base and height. So looking at this triangle, we have our base. 14 would be on the bottom. And notice it kind of extends out. That's okay because we don't have a straight up and down on this one. So base is still on the bottom. Our height, even though it's outside that triangle, it is still on that right angle. And remember, when we have a right angle, base height. So my height in this one would be 10. All right, this one, this is called a right triangle. We would again have our base at the bottom. So this one's pretty easy. And then height, we have that right angle. So height would be 6. And there's no slants on that one or that one. So those are pretty easy. All right, and then we have this one, again, base is bottom. We do have a right angle, so we can kind of pay attention. That's going to be base height. So my height is 9. It's on that dotted line. And then we do have some slants, so we can go ahead and mark those out so we don't get confused. All right, so base is always on bottom, height is up and down. So now we can look into the trapezoid. So for a trapezoid, we have a little bit longer of a formula, so we can write that down. A equals 1/2 B plus BH. There's some parentheses in there. So A equals 1/2 parentheses B plus B H. So B, we have two B's, that means we have two bases. We also have a height. So when we are looking, we need two bases and a height. So when I'm looking at my trapezoid, my base is on bottom, okay? So this is one of my bases. And then we're gonna go directly above the height. This would be my other base, okay? Notice bottom, top, all right? To find my height, we can look for that dotted line. We also have our right angle, so my height would be 4. Now, the 7 and 5, since they're kind of on those crooked lines, those are my slants. We're gonna get rid of those, okay? And again, trapezoids have two bases. So this is another type of trapezoid that we could have. It has two bases, so bottom, which is always our kind of easy one, and straight above it is my other base, 5. Okay, we do have a right angle. We don't have a dotted line, but right angle tells me that this straight up and down is my height, and this kind of sideways one would be my slant. Okay, so now that we have labeled all those, let's look at some questions that we could use. All right. So example number 1, which expression can be used to find A, the area of a trapezoid? So our key word here is area. When we see area, we're gonna write our formula. And it even tells me I have a trapezoid. So I am going to write down the formula for my trapezoid, which is A equals 1/2 B plus B H. Okay? So they want us to say which could be used to solve this, okay? So they all have 1/2, and then we're just gonna plug in our numbers. So I need two bases, so let's label our bases. We have our bottom, and directly above, we have our top. So let's go ahead and plug those in. If I have 1/2, that's gonna stay the same. My first base, it doesn't matter which order we put these. It looks like the 6 is first in most answer choices, so I'm gonna put the 6 plus 8. And then we need our height, okay? So remember, we cannot use slants. So let's go ahead and mark our slants out. So this sideways one is a slant, so we cannot use 7, we cannot use 5. So if I look at my answer choices, if it has a 7 or a 5, it is automatically wrong because those are slants. So this one has both. A is definitely out, okay? B also has a 7, so that one is out. Okay, all of these numbers are good here. All of these numbers are good here. They don't use a 7 or a 5. So now I can look for my height. My height, I have a dotted line, and I have that right angle. So that would be my height, which is 4. So now we just find our match. So looking at C, I have 1/2, I have 6, I have 8, I have 4. But right here, they have multiplication instead of adding. So C is not correct. The only one that matches everything is D. So that's all we're doing on that problem. All right, example number 2. A rectangular computer screen has an area of A square inches. The width of the computer screen is 16 inches. Which equation represents X, the length of the computer screen in inches? So first thing I saw was area. So that means we need to write the formula, and it tells me it's a rectangular computer. So that means rectangle. So let's write our formula. Let's look at the star chart. So a rectangle is A equals BH. Okay, so let's write that down. A equals BH. And we talked about that means to multiply BH, base and height. But if I'm looking in this problem, they didn't use the words base and height. They used length and width, which is kind of the same thing. They used width and length. So that's, we could say A equals length times width. Base height, length, width are the same thing, okay? So let's plug in what we have. It says an area of A. So A is going to stay for my area. So let's rewrite that. I have A equals, okay, the width is 16. So when I have a width, it is going to be 16. Okay, because it says a width of 16. It says which equation represents x, the length. So they want me to use an x for length. So I could write that as x times 16. Length times width, x times 16. So if I'm looking at my answer choices, I'm noticing that my x is by itself, not the A. So we know how to solve for x, so we can do that. So if I was to solve for x, I would need to move this multiplying 16 over here, and the opposite of multiplying would be dividing. So I would need to write A divided by 16 equals x. So we know dividing can look like a fraction, but the A is on top. So if I look at A over here, 16 is on top, which we know we can't switch a cowboy and horse. This one has adding, so B is out. This one has a 2 in it and subtracting, so that one's all kinds of crazy. And then this one, we have X, A is on top, so D would be our answer. All right, and then let's look at example number 3, last one. So it says, Tim has a set of plastic squares. The table shows the relationship between A, the area, so already got my keyword, of each square, so we're talking about square, in square centimeters, and S is the side length of each square, so S is the side. Which equation can be used to represent the relationship between A and S for these squares? So this time they give us a picture, okay? So the top is A, so these are my area. So these are all area. The bottom are my sides. And then they give us a bunch of formulas. So I'm gonna pick one row to look at. And a good strategy to do is to pick the last row when we are working with tables like this. So I am going to use 64 and 8. And again, 64 is my A, so I'm gonna go ahead and label this as my A. And my 8 is S. Okay, so anywhere I see an A, I'm gonna write 64. Anywhere I see an S, I'm gonna write 8. And then we can just see which one works. So A says A equals S. So that means 64 equals 8. So does 64 equal 8? No, so A is bad. Okay, let's look at B. It says A, which is 64, equals S, which is 8, times another S, which is also 8. So 8 times 8 does equal 64. So that looks pretty good there. So let's look at C just in case. So A, 64, equals 2 plus S, which is 8. 2 plus 8 is 10, which is most definitely not 64. So that one does not work. And then lastly, A, 64, equals S, which is again 8, plus 8. 8 plus 8 is 16, which is not 64. So the only thing that works on this one if we plug in our answers is B. So big thing you need to know is keywords are area, and we are always going to use our star chart to look for those formulas. You do not have to remember them.